Greetings, Internet. It is I, Dark Mage. Welcome to Evil Dojo presents raylib game development in C++. We had a really positive response to the assembly language video, so I want to thank everyone who has thumbs up, liked, and subscribed and whatnot. That was fucking awesome. We're gonna do more stuff like that going forward, but we're going back to C++ and we're doing something new. We're doing a few new things since last time. I want to show you. Let's change this value first. I'll show you what I've done. We've refactored a lot. We're making things a lot more modular, and we're playing around with some new mechanics. I've disabled bat spawning, knives, and whatnot for the moment in favor of something new. Hold on, I have to make the screen capture big. Alright, let's try that again. Check it out. Okay, now I'm gonna press the space bar. Oh, that's so cool. Now, we're gonna press the space bar again. Does this remind you of anything? Does this remind you of anything? Anything at all? Well, this reminds me of a game that I played when I was working for the first corporate environment that I ever worked for, and that was a game called Flappy Bird, which is a really fucking amazing game that I wish I still had. I had it downloaded on my iPhone 5S back when that was, you know, like one of the current phones, and it was a fucking amazing game. I managed to snag it before they took it off the App Store, and there's probably countless clones already that exist, but it's by far time that I, you know, worked through the mechanics myself, because in developing an entity component system, one of the components that we're able to kind of finagle together is the concept of gravity. Now, I haven't done it in a entity component specific way yet. However, I have worked through the mechanics to make gravity actually work, and not only that, but also to allow the player to bounce up in an effective jump motion that would allow them to jump higher and higher and higher if they need to. So there's a lot of different ways that we can go forward from here, and I'm kind of torn between them, so maybe we can work through this. I want to be able to have two or more modes of gameplay, one at which the skull is progressively going higher and higher, and you have, you know, like the big penalty there is if you get lazy and accidentally fall a very far, you know, distance, right? And then the other mode of gameplay would be like an infinite falling setup where you're just going down nonstop. Between these two modes of gameplay, I want the other shooter mechanics to still apply. Like, this is basically going to be Flappy Bird on crack at this point. It's going to be like Flappy Bird crossed with Gothic Gradius, and that's, I think, going to be really fun. Not only for me to play, and if it's fun for me to play, it's going to be fun for everyone else to play. Like, just straight up. So, that said, let's get cooking. What are we doing first? So what I think we're going to do first is actually going to be like, maybe crank the microphone up. Fuck, no. We're doing post-processing on the audio. There's some fuzz when I'm recording by default that I haven't figured out where the fuck it's coming from, so I apologize for that. If there's any fuzz, I'm going to do my best to eliminate that from the final product. The first thing we're going to do today is actually step backwards a little bit, because we're defining scenes now, right? Originally, a lot of this functionality was available in the game class, which held, you know, pretty much 100% of all of the different things related to handling gameplay and rendering the screen. But now we're doing that inside of scene. The reason we're doing it inside of scene is we want to be able to define multiple scenes that are different, right? Like, for instance, in the raylib template, we've got different screens that are defined. The way that they handle them is a little bit weird, but it's essentially the idea that we want to go for. So for instance, we have a title screen, right? And in title screen, they define a lot of functions that get called by the main system. And it's so long as you define these functions, you can pretty much just replace them with whatever code you want, and everything kind of works together. And if you need other screens, you can define them and add them into the system. But this was defined kind of as a good starting point for understanding how things work together, but the code flows really weird. So we're going to do a lot of that ourselves using C++. In today's setup, I've got the compiling loop on the left-hand side and the code that I'm going to be working with on the right-hand side. So whenever I save anything, what's going to actually end up happening is we completely clean the build by deleting all of the object files and the binary that gets produced, and then recompiling everything from scratch. So one of the things that I'm going to need to be able to do is subclass scenes, so I can have different scenes that have different environments, essentially. All of the scenes are going to be very similar in that they're all going to have things like a map of textures, a map of sprites, a map of background sprites. At the moment, I'm playing around with the idea of stars, but you know what, while we're here, let's just kind of temporarily take this out. The main reason I had it in there to begin with was so that we could have like a nice looking, I should say, background, so that it demonstrates the jumping up and down kind of nicely. Actually, we could just leave that in there for right now. We'll be able to take it out later. But if we wanted to take it out like without removing those things, where we call add star in our initialization function, we just comment this loop out, which simply adds 1,000 stars, and each star is placed in a way where it's randomly selected between like the currently visible screen and then going up, which of course is the negative Y direction. I'm realizing that if I pause in between recordings and speakings and actually take a moment to just not even necessarily think, but allow the thoughts to flow, then I don't feel so much pressure as to being forced to constantly be talking on screen. While this makes for a better product, the way that I have to stitch these videos together does not flow with my normal mode of speaking. So this is working for me though. I also hope it is working for you. But one thing that we do need to do, so for instance, if I save this and we rerun the program, now there's no more stars, but you can clearly see where the player is and where the ground is at. We're actually not doing a very good implementation of the ground check at the moment. So for instance, if we wanted to show the code where that is being handled, right here, lock the player to a relative ground location. This isn't very good. It's very hard-coded. What I would want to be able to do is define arbitrary vectors that represent essentially like normals or normal planes. where if the player comes into contact with that location, then he can't pass through it. Which would be essentially like a collision detection, but we're not even doing that here. We could re-implement this to use such a thing, but I think before we do that, what we really need to do is actually go through the process of generalizing scene so that we can subclass it into multiple scenes, just like with the raylib C template. What this is going to involve for us is setting up some of these functions to be virtual functions. As an example of this, and actually flip, that's probably a bad named function, but I'm not going to worry about that right now. One of the things that we are going to have to template out, or rather make a virtual function, perhaps the init? No. I thought about this the other day. Hold on. Ah yes, that's right. The update function. So let's go to update right here, right? So this is very hard coded in, but the process is going to be similar. Like in every scene, we're going to go through all of the sprites and necessarily need to update them. But for instance, between two different scenes, the controls that the player might want to have available might differ. So as an example, for instance, if you're on a title screen, there's really no reason to have a camera input. There's no reason to have a player input. You're just making selections. So from a title screen perspective, handle input should be different than it is here. And if we want to be able to have different implementations for different functions, then we need to subclass scene and then implement different handle inputs for them. Similarly, if we had something different with update, which actually was my first thought, then we would need to do that too. Like for instance, with the way that the camera follows the player on the title screen, there might not even be a player ID on the title screen. So the update will probably be different because we won't be making references to player ID. So understanding that this is what we want and that we ultimately today want to end up with a level 1 scene or a main game scene. It'll start off as main game, I guess, just for like sandboxing. Then a title scene and a game over scene. I think this would be a pretty good feedback loop to get into. And then we can disable the title screen and also set up transitions between these scenes, while at the same time teaching y'all a little bit about polymorphism. I think this is a good goal for today. But first I have to charge up my power level so that I can go Super Saiyan. Alright, step 1. Let's go and clean up the environment. So as an example of this, better yet, yeah. So we're going to declare update to be, actually, update? Yes. Update is now going to be a virtual void. So will init. I think draw is okay. Draw is generic enough that it should be shared across all subclass versions of scene. Load textures and load texture should all be very similar. Debug panel, camera stuff, all that should be similar. Handle input is going to be virtual. Cam input and player input perhaps should be virtual. Load font should be the same, close should be the same. Spawn entity, spawn player, because we don't necessarily need to spawn player every time, but it'll be shared across all the functions unless we decide that we want to shift the texture or something like that. And then of course add star still in there, and then all of the different... Actually, we do have a gravity component, but I don't believe we're actually using it at the moment. We're just ready to use it. All of this stuff should be the same across the different whatnots. So game still works, of course, because declaring these things to be virtual doesn't really do a whole lot, other than tell the compiler if we subclass these functions may or may not have new implementations. So now that we've done that, right? Like, what if we wanted to create a title scene? Oops. I'm going to create a new title. So we're copying over the .h file for the scene object. We're also going to copy over the scene.cpp into TitleScene.cpp. So now when we go into TitleScene.h, we're going to declare this to be a subclass of scene. So in order to use the scene class, we have to, of course, include it. And because this is a title scene, the name of the constructor is different. Now, when we go to implement, update, and init, and we go to implement our overloaded function, it's no longer going to be declared to be virtual. So right here at the update and the init, and because draw's implemented for us already, so is debug panel, so is all this stuff, so is all that stuff, and these things we're going to be implementing ourselves. And then these are already done, those are done, those are done, that's done. So now we've stripped it down significantly. But we have to add it to our compilation here. Uh-oh. Big error there. Probably because we never actually remove the definitions from the title scene. So we also are missing several other things like title scene, Oh, and yeah, we have to, of course, include TitleScene.h up here. Now, when we go to initialize, in order to call the super constructor, I believe because this is a title scene, title scene constructor would get called after scene. Similarly, we have to declare this to be the destructor. Now, for a lot of these things, they're declared for us, but things like update, things like, let's see, just gonna run through and take care of stuff as I come across it. So update, we actually really won't have like anything moving at first, so there's no reason to really have stuff. Handle cam input won't even be a function. Handle player input won't even be a thing yet. Handle input will be a thing, but we won't have player mode or player cam. It'll be like play control mode title screen or something like that. So that's like, you know, we're very specific about what it is that we're doing. Draw, I don't believe we need to implement this. Init is something that we do have to implement ourselves. Load textures, no. Same with load scene or load texture there. Set camera default values. Draw debug panel. Although we might have to be careful about that one. Set global scale. Load fonts. Spawn player. Entity, and add stars already done for us. So, and then we need to do these. So most of this is actually commented out, but we do have to implement update and init. Because the init is essentially how we're gonna like pass things around, and load textures, the way that we're doing that at the moment is through a texture file path. So like before we call scene init, set the texture file path, right? So like for instance, instead of calling it assets, we can call this main game textures. Or rather, game textures. Because that way we can have different things per scene. So for instance, we're going to go ahead and move assets into game_textures.txt. Now this way we can actually do a game texture and copy that over into title textures.txt. So in title textures we could have title, which would be 1, it's not a player, and it's located at like title. So actually here's title 1. Let's go ahead and get this in there. So actually let's look at the both of them. Okay, so you can see where the inspiration and difference are. But let's go ahead and get title 1 in there. Right? So over in game, see multiple definition of scene updates. Let's see. So when I implement it, do I need to declare it virtual too? So over in, we gotta declare update and init in scene.cpp to be virtual. Oh, inside the class definition? Okay. So, well, that was correct then. But I guess over in title, oh yeah, I hadn't changed 34 to title. This also needs to be title. Okay. Alright, let's see. Unfind reference to handle player input. Oh yeah. Alright, it built. Hell yeah, we got over those errors. Fuck yes. Alright, let's fucking go. I'm running out of coffee. This is a problem. But we're gonna push onward until the cup is empty. Now that we have a title scene, right? Like, we could actually just specify the texture file path right out the get-go and say this is title textures. Yeah. So that's title textures, and then when title scene calls init, this is what gets called. But this is custom per scene now. So what we need to do is comment out all of the stuff pertaining to spawning the player, and instead what we need to do is spawn an entity with the title. Now, we need to define a new sprite type. We're going to call this title. It really doesn't matter what order, but I'm going to try and make this in terms of order that things appear in the game. You know, from program load perspective. So if the title comes before everything else, it would be the first sprite. So, operating off this principle, let's go back to game.h, because here we have hard defined a scene called scene, but we're ready to start doing multiple scenes, kind of, and we want to get a title displaying right now. So, to start with, we can actually comment out the old scene and replace it with a new one, and just add in title scene right here. Now we have big error because we have a lot of stuff in game.cpp that was calling on the original scene that we now have as title scene. So close is inaccessible, as is draw, as is a bunch of other functions. Why not? Okay, less than 5 minutes of Googling, and it looks like I'm just missing the public keyword from the derived class. It's been a while, so knowing you can do this, and this should actually fix everything. So what happens if I run the game now? Things will probably be broken. I totally expect this. Naturally. Naturally things crash. Let's crash it again. Okay. So, let's take a look at game.cpp, see what we're doing wrong. And actually, I think... Oh, it's still trying to load bat for some reason. Oh, I know why. I think. Game textures. Oh, that's not right. Yeah. We actually set it in the constructor for title scene, so we no longer set the texture path there. Error texture file path not set. Scene 196. Load textures. But we're not even using the regular scene anymore. Error loading scene, error loading textures. So on 175 the title scene. So, when is a init call? Oh, the texture file path is set right here. Does it get wiped out somehow? Alright, so I guess we'll just put that back in there and change this to title textures. Alright, so it loaded successfully. That's good. But we're getting some sort of error here. Let's turn off drawing the scene for the moment. And you know what's probably the problem? Like I was saying earlier, in our debug printing, we're attempting to print print or like access something with player ID when it doesn't exist. So naturally we wouldn't be able to do that. Okay, it's not crashing. That's good. Oh, good, good. You see the title in the top left? Oh man, the system's starting to work. Okay, watch this. Okay, so we have no input at the moment, and we're about to fix that. What did we set the global scale to on? Let's see, in scene, for draw, we're at the moment drawing this rectangle still, so this is going to be universal. So we'll probably want to make draw virtual as well, now that I think about it. Or we might want to have like a chain of different draw calls. I'm not exactly sure how the best place or the best way to go about doing this one is at the moment, but we're gonna figure it out. If I get everything down to sprites, it really shouldn't be a big deal. So global scale, we set it 2x. We'll start it off at 1. Now see, that's tiny, you can barely see that. Let's make it huge. Oh, that's way too big. Okay, that's much better. Handle input, right? If D, so why is the D key not registering? Alright, let's take a look at the scene. Alright. Oh. We're overriding it with ours, right? So... So this should be being called from within the title scene, right? Yeah, a lot of these are shared. So, for instance, title scene 69. Control mode is private within this context. So I guess on scene, I would need to define set control mode. And then here we'd have to also do like set texture file path. Alright, and then 167 has been initialized. $191. Okay, so that gets over a lot of the permission issues that we were just experiencing. Let's take a look at what it's doing now. Alright, now we've got responses. Now we've got an actual title scene. But we could definitely center that, right? We're doing it at 0, 0, but this is what I call like good refactoring practice. Start off with something that works, then you work backwards. You introduce variables for all of the constants that you might be using, and that way you've got a bit more of a more configurable setup. It's a lot easier to edit individual variables than it is to jump into the middle of a line of code and change values over there, when it'd be a lot easier to just make a reference to some other variable like the constants here, and then define these constants to be in terms of get screen width divided by 2, get screen height divided by 2. Now, in addition to this, because it's a title scene, we want to get the reference to the width of the title that we're about to use, which would be in the sprites with the title key, and we just call get width on that. Same thing for the height. Now we have reference to those, but the sprites are private. Whoops. So now we actually have to find a way to make a reference to those sprites, which is going to involve going into scene, make it like, oh, okay, we have an unordered map here. So let's say we wanted to like return a reference to it, so we could just directly access it. So we could actually we don't want the textures, but we definitely want the sprites. So now over in scene.cpp, we're going to go and drop this new function in. Because it's a reference, we don't have to worry about cleaning it up. Now over here, we can say get sprites. Ooh, that doesn't work. What if I wrap it in parentheses, like Java style? I still don't like that. Oh, it's an arrow. No? We haven't rebuilt it, have we? It doesn't like that. Oh, right. The sprite's an ID. And actually, we haven't even spawned it yet at this point. We were actually trying to get the textures, and yeah, we are actually going to need to return the texture now that I think about it. So, so we're going to do the same thing for get textures. Alright, so now, back over in Title, we should be able to make a reference to get textures. Did I mean to use dot? Let's see. There we go. Now let's take a look at this. Oh, it's way off screen. Okay. Let's keep it anchored to a quarter. Or let's leave it like that. Make the offset half. Still too far off. Still too far down. I like the quarters. That's too far over. We're gonna do a quarter of the height of the width. No. Oh, but yeah, I forgot we're resizing it a lot, right? Like the global scale that we set in game is much bigger, so we have to account for that too. So I actually set it to 32 there. So now we have to account for that. So over in scene, we need to introduce a float get global scale. Okay, that's a lot better. It's a little bit too far over though. Alright, that's starting to get pretty close. I think for right now this is a good start. What do y'all think? So from here we aim to directly jump into the next scene, which would be of course the gameplay scene. So in a similar way that we subclass this title scene off of the main scene object, we're going to do the same thing for like our sandbox gameplay screen. But first, let's go ahead and check this code in. Of course, we want to echo game textures and add that to our getIgnore. Same thing with title textures. Let's take a look at everything that we've changed. Not a whole lot. Okay. This is a good pattern going forward. Of course, you can find all of this code at the following. Over here at raylib cpp template on my GitHub at Mike Desu. So follow along, hit me up, do all that good stuff. We're gonna have a lot more here going forward, so I think at the moment it says I'm using WTFPL, but I think I might change that to my own. And it is about time for me to get something to eat, as well as some more coffee, if there is any. I'm thinking crackers, turkey, cheese. Oh yeah, we have hot dogs from yesterday. Happy 4th of July, everyone. Go Team America. Alright, I think we're ready for part 2 here. So let's see. We just set up the title scene. Title scene is a subclass of scene. Excuse me. Certain functions in the scene object are declared to be virtual. Anything that's virtual has a defined method here, but it essentially needs to be overloaded when you subclass it. So every time that we decide we want to define a new scene, and we're defining scenes by defining new classes, then we're going to have to attach that information. In order to modify private values that might exist in the higher order class, we're going to have to use setter methods and getter methods in order to access and manipulate them from the subclasses. Other than that, it's a pretty straightforward process. We take a look at TitleScene again, and we were to clean this up a bit. You see that we only have a very small number of functions in the header file that we actually have to declare. And in the CPP file itself, we have much less code that we actually have to define right now. Of course, in other scenes, when we start introducing collision and mechanics again, there will be a lot more that we have to take care of inside of the update function. But to begin with, all we have to do in order to create a new scene at this point is copy, let's say, TitleScene.h into GamePlayScene.h and do the same thing for the CPP. So in GamePlayScene now, we need to change title to gameplay. And then we need to go into GamePlayScene.cpp and change all of the references from title to gameplay. And that's it. We need to also add it to our make file. So we create a new rule for it, we add it to our object files list, and we're good to go. We need to also build and run everything again. As you can see, no errors. Now, GamePlayScene is currently just a dead copy of the original TitleScene. So, for a moment, let's comment out any code that might actually instantiate. So here we don't want to do any title or any sort of textures. Or better yet, we can actually go ahead and set this to what? What's the name of our game? It's game textures. We have to add to the game.h and include that pulls in the gameplay scene file. So we're establishing a pattern. So eventually we're going to have some data structure to hold and keep track of all the different scenes that we're actually instantiating, because we're going to need to be able to swap between them. But for right now, let's go and comment this one out again. Create a gameplay scene. Now, gameplay scene is calling all of the same functions that the title screen was calling. So for instance, we're setting the title texture right there. We actually don't need to. So we're now doing it when the object is declared. Let's try running. Okay, so far so good. Now, over in scene.cplusplus, we have a spawn player still. Now this we can actually copy over. Actually, I want to take a look at scene.h. So spawn player is defined here. So that means we'd be able to call it here. So for instance, over in the init, we just pull that code directly over. Textures, we're gonna have to call get textures. Here, same thing. Get textures. Alright, there's our skull. So we're back in business there. I think we have a pretty good pattern of attack. So, one question I have at the moment is how do we actually transition between one scene and another, right? How do we actually, say, start with the title screen and then switch to the gameplay scene? So for instance here, something as easy as just commenting one out and uncommenting the other. Everything still builds and we still get title scene now. And if I were to comment this out and uncomment this one, rebuild, all of a sudden we have our gameplay scene. So we're able to swap between the two very simply now, which is very convenient. But we can imagine a way to join this process together. We can think, okay, well, when one screen is done, I want to move to the next screen. Perhaps I want some sort of animation to like illustrate the transition, like a fade out and a fade in. How would we go about implementing this? This is a little bit tricky. There's a lot of ways that we can think about it. Is it more important for us to do that now, Or is it more important for us to do that later? These are the kinds of questions I ask myself as a game developer. I think, what is the most important thing to work on at the moment? What is the most critical detail? And while this is not particularly fun or interesting in terms of actually making something that I think people would watch or be interested in, but when it comes to the smooth transitions when you actually sit down to play the game, this is something that I think most people would actually notice and care about, and gives just a little more oomph, if you know what I mean, to the whole gameplay experience. To be able to get into a very quick loop where you see the title and immediately start playing the game. So let's take a look at if we were to make TitleScene the main thing right now, and then take a look at game.cpp, how we're actually calling things in scene. So during our game call to handle input, we actually call scene handle input. When we call update, we call scene update. And when the draw occurs, we enter into texture mode, and then we begin the scene.draw. And then we actually close the scene. So remember that the only things that we really have to define ourselves are the init, the handle input, and the update, right? Pretty much everything else is handled for us. So knowing that stuff's handled for us, how can a scene return information to the game? Like the object, like the scene being a property on the game object, and being involved in this loop, right? So in the run loop, we call handle input, which calls scene.handle input. We call scene.update, and then we call draw, and that calls scene.draw. So we would want to perhaps store the scenes in a map or an array of sorts and identify them with unique identifiers. And then that way, each instance where we're calling a particular scene.method, we'd be able to refer to like which scene we're currently on. But even then, let's say we press a key on the title scene, right? So we have handle input, which allows us to flip the debug panel. But we want a way to return information to something. We want to return some value. We want some function that we can call from the parent, right? Because perhaps a scene transition occurs as a result of you pressing a key on the title screen. Or perhaps a scene transition occurs because you die and you're transitioning to the game over screen. Or perhaps you're on the game over screen and you press a key to restart the game or go back to the title screen, or something like this. Perhaps we could attach a value to the scene object to indicate whether or not we're transitioning into or out of the screen. I'm thinking we could have a struct to enumerate, or some enum, say screen transition in, screen transition out, screen transition none. You know, we don't need that many states, right? Like, but when we're on a scene, we want to be able to like press a key and then have some value on the scene update and have that value be read by the game. So in our update, right here, we're going to want to do a little bit more than just scene.update. Actually, where does handle input come from? So actually that happens first, so when we actually want to like fade in and fade out, we're going to want to register that there has been a transition initiated and then initiate a screen fade. Once that fade is complete, we're going to want to swap the two things that we are actually working on, like the scenes, actually change like the current working scene, and then we want to fade in the next scene, right? So over in scene, let's start with a typedef enum scene transition. So we have a scene transition in, out, and none. Actually, I'm going to make that scene transition. Alright, so there's our accessors. Alright, so there's our accessor methods. So now on the title scene, I'm going to have the player press space to actually so when we actually instantiate the title screen to come in, we're going to want to do a fade in, but I'm not doing that to start with. To start with, we're going to do the scene transition out. To begin with, I want to take a look at how fading is done. So over in our scene.cpp in our draw. There it is. Actually, it's not even going to be here, it's going to be in game. No. Oh yeah, there's scene.draw. We're doing it directly to the texture, and then here's the draw for the render texture. So each scene is actually drawing to a master texture that's controlled by the game object. So you can imagine that there's a way to apply a fade here. I've seen it done. So we have a fade right here, and we'd be able to do something like, for instance, this is an experiment to test this out. You can apply arbitrary fades to the texture. Sync. Yeah. Yeah, that makes sense. Did it just like transition in though? It looked like it did, or something. Well, it's having trouble calculating or something there. But it looks like it's applying some level of fade. So there's a little weird effect happening up here. Not sure y'all can see that, but if there was like a fade object, or like a value we had on the scene that's like float alpha, and then you can just set and get it like that. Now we have the ability to set the alpha and get the alpha on any given scene. Here what we would do is scene.getAlpha. Now if scene.get scene transition equal scene transition out, then it's going to, I don't know, we want to flip these, and even then we're not handling in at the moment. If the scene alpha is greater than 0, we're going to subtract. Oh, it's definitely breaking something in the background. It doesn't like that for some reason. It's also not clearing the texture. This is interesting. It might be also kind of expensive to fade out a render texture like this. Now we have scene IDs. Over in game, we can actually declare a unordered map of scene IDs to shared pointer scenes. That way we can have different scenes in there, and we'd be able to attach a gameplay scene and a title scene. So for instance, at the top of game, in our init, we can have a shared pointer title scene. And then we can make that our map. Hold on. We also need a scene ID or some sort of next scene ID. Okay, it's just set ID and get ID. No, we don't want to init it yet. So in our scene map, this might be one way we go about adding a scene to our scene map. Do we need to initialize every scene right away? We may not have to. We might want to. I don't know yet. But scene.init's no longer going to work. We also might need a current scene. Better yet, Do we have a shared pointer to a current scene? As you can see, it could be done either way. Well, let's do something to break things to force us to do it correctly. So now we no longer have scene defined because we're using a scene map. And 84. As an example, no longer doing scene.handle input. We are doing scenes of current scene ID handle input. Similarly, with update, we're no longer doing scene.update. We are now doing scenes of current scene ID update. So on 117, scene.draw is no longer what we're calling. We are now calling scene of current scene ID.draw. Scenes plural. This doesn't seem to work the way that I expect, so I'm going to comment it out. Then on 153, for right now, we're going to fix this so that it calls appropriately, but in the end, depending on how we manage the scenes, we may or may not have to individually close scenes as we transition in and out of them. But we only have one scene at the moment. Let's say we wanted to make a gameplay scene. So everything's loaded in now, but we need a way to very quickly and easily associate scene IDs with their intended purpose. So for us, perhaps something we could do perhaps we can get a list of scene keys. Because the scene IDs are meant to be generic. So if we wanted to, like, say, map the title to its ID, we could do something like this. And then if we wanted to do gameplay, we could do something like that. And that way, instead of having to do title, scene, get ID, we could actually do scene keys and title. And if we wanted to be very careful about how we did this, so if scenes of current scene ID pointing to get scene transition, we'll transition out, then current scene ID will get the gameplay. So with any luck, now when we press space on the title screen, it should drop us into the scene with the skull. Yes. Okay. It's rocking. It's really fucking hacky, but it's rocking. Let's go ahead and clean up. We'll get around to fades. We'll figure out how to get the fade working. So a lot of this stuff is going to get pulled over into the gameplay scene. Every debug panel as well. Actually, one way we could do this is by using another one in order to specify what the next scene should be once, we receive some sort of event in a particular scene. That way the game object can make a decision about which scene to load next by making an associative map between the enums and their appropriate scenes. However, separating out by ID is not a bad idea either. Let's commit. It's a lot of code we just did. Remember I said before that we're going to need a separate debug draw debug panel? So for instance, let's go and yank all of this over. We're gonna need some more accessors. We're gonna need to do unsigned int scene get current frame. Now over in TitleScene, we actually do get current frame. We're going to call the accessor method. We're going to do get control node, which hasn't been written yet. Back in TitleScene on 64. We call get camera 2D and get camera 2D. global font, we're going to need to write an accessor for as well. Now right here, instead of calling global font, we'll call get global fonts. Now to show that we have two different debug panels, this one's going to start off with the word title scene at the bottom. You see in the top left, words title scene appear, then we hit space. Now they don't. So to customize this on a per scene basis, let's open up GamePlayScene, hit the bottom, paste our method, say it belongs to GamePlayScene now, copy that line, and now we paste it as a declaration in the .h file. Now in GamePlayScene, at the very end, we can mark this by saying GamePlayScene. Now, when we transition scenes, do we need to close the previous scene? Everything seems to close without crashing so far. It doesn't appear that way. I mean, that we need to do that right away. So let it run for like 1,000 and then transition. And we'll see that each scene has its own gameplay, or sorry, its own current frame count. That way we can keep track of how long each scene is run, and we can also copy each frame value if we want to keep track of how many frames have run for the total game, and keep that as a separate variable if we want to. I'm going to take a little bit of a break here, and we're going to come back and implement add in those flappy mechanics to our gameplay screen, so that way we have two functionally different screens that we can work with, and then we can start working on a game over transition as well. And also maybe along the way I can figure out how to do these damn fades. That would be cool. Rayson actually suggests drawing a black box on top of the render texture. That might be it. Let's see if we can hack that together real fast. Alright, so instead of doing this, Oh, that was way too fast. No. Let's see, how do we do the debug panel? We actually draw a rectangle and then text on top of it. And here we're setting the fade. So really what we want to do is set the fade on every new scene. Actually start at 0. Oh, there you go. Oh, shit. That looked fucking great. Okay. Let's do that again. We could even make it, another color, like red. Oh, look at that. That's sick. Oh, that's sick. Oh, it's so sick. Oh, it's so good. Look at that transition. Oh my god. Okay. Okay. Can I apply my favorite shade of gray? It's pretty fast. I like that. So we could actually move that out to a function. So in order to properly fade in and out, we're going to have to set the alpha for the scene. There we go. Alright, that's pretty clean. So whenever we finish transitioning out, we need to trigger the next scene to essentially switch places with the current scene, and then also handle an appropriate fade in. Actually, we might default setting the alpha on the scenes themselves to 1.0 in order to facilitate that. Let's go and do a check-in now that we got that working. All right. You're ready for part 3? Last we left off, we had pretty smooth transitions occurring. A couple small details, but now when we fade out from the title screen, we want to switch to the next scene. So to begin with, we're going to do something a little bit hard-coded. We're going to close the fucking door so we can think straight first. It's so goddamn hard to think with a fucking laundry machine right next door going 24/7, and also a Roomba within earshot as well. It's already bad enough that I've got my own ambient noise creating stuff in my room. Fuck. Alright, let's begin for real. Last time we left off, we had a nice fade in, fade out kind of thing occurring. And we want to, when we're transitioning in, we set the scene transitioning on. When we transition out, we want to go to the next scene. We want to so Copilot is thinking that we have something defined that we don't. Get next scene ID is not a method that exists on the scene object. We're not implementing this as a list of scenes. So we have something here called a scene key, and when we created the scenes to begin with, we set a scene key that is equal to the ID associated with it. We could even attach a key to the scene object itself in order to make this process a little easier. But to begin with, let's hard code something in. So we're transitioning out. We want to set the current scene ID equal to the gameplay scene. And this should facilitate a very straightforward transfer of control from one scene to another. Let's see if this works. That worked! Oh shit. Alright, so we want to probably default the debug on any new scene, perhaps to be default off. Now there is a bit of a flash there. It's not exactly appealing. That looks good. That looks really good. Let's do that again. Oh man, that's so nice. Okay. I'm like actually smiling about this right now. This is fucking awesome. This is essentially everything that I wanted to implement over the last couple days. But it's not enough to stop here. At the beginning of this video, I showed y'all the Flappy mechanics, and it would be very nice to get those reintegrated into the system so that as soon as we press spacebar, we transition to this gameplay screen and we start playing. So before I do that, let's check in what I've got. Really didn't have to do a whole lot this session in order to get this working, which is very nice. So we're going to reintegrate Flappy mechanics into the gameplay scene. We have not defined anything in the update yet. Over in the update, for the original scene, we have a bunch of code that exists already that was still the original code that I used to implement the Flappy mechanics to begin with. Going back into GameplayScene, pasting this code for auto-s-in get sprites. Notice how everything still works. Almost. So here we have to say get sprites of get player ID. Now, we're not going to be able to set target this way. We're going to have to do something else. Actually, one thing we can do is get a reference to our camera 2D object. Okay, get player ID is not a thing that we have access to yet. Oh yeah, we haven't saved that yet. Undefined reference to get player ID. Oh yeah, we have to implement these still. Alright, so now we have set player ID, get player ID. Everything files. Let's see what happens. Alright, so we have no information about where the skull is at. We could definitely print this out. Alright, so the player's position's locked now, and I noticed that it was moving at the very beginning. Our draw method is currently genericized across all scenes. What this means is that we want the functionality for every scene's draw method to be the same. We want to iterate over a list of sprites. We want to draw them, and that's that. Something I'm doing here is I'm actually drawing stars in the background, if we have any, and I'm drawing a, well, here, originally I was drawing a rectangle to represent the ground that the player lands on, We can shove that back in and it's going to show up during the title screen load. You see it there on the bottom. And Skull drops to the bottom of the screen here. So where did we call add stars? In the init initially? So we should have some stars drawing too now. Nice. So, because this is like exclusive to the title scene, or to the gameplay scene, they don't actually show up in the other in the title scene, right? So this is how we can keep things scene specific. So over in our handle input, so going back over here, take a look at handle player input. Updating these so that the access is correct. Alright, we just changed all of those using some Vim magic. There we go. We are in the game. How high can we go? I know it goes pretty far up, so how about let's stop here. We're like negative 11,000 on the y-axis. Let's just fall straight down. Nice. Very nice. So one thing that we would want to do going forward, right, is instead of having like a hard-coded thing in our draw function here to represent the ground, we would want a real ground sprite texture. And we would also want real stars. You can't really tell from here that he's moving. That's the whole reason I had the stars and the ground in there to begin with. So as an example, before we get a real star in there, let's load up the soul shard, right? I really like this little thing, and we can export this to a sprite sheet, import it into the game, and then spawn it in the places that we were originally spawning stars. So here's our sprite sheet for the soul shard. So Soul Shard has, what, like 8 frames of animation? Yeah. So back over in Scene, we had a add star function. Alright, so in this case, we want to actually spawn an entity. But we don't have a sprite type for Soul Shard defined. Now we do. So instead of calling add star, we're going to call add soul shard. Now that's interesting. The soul shards look like they may or may not be spawning correctly. So whatever the global scale is at the time of us adding it, that's what it gets set to. And I believe by this point, the scale has already been set at 4. Maybe we didn't get the file name correct? Yeah, it says soulshard-sheet.png. It's right there. Oh, it's loading it with a new line at the end for some reason. I don't know why I would have a new line at the end. Maybe it's because it's the last element in the list. Okay, that looks correct. Oh yeah. Nothing's animating, but that's exactly what we wanted to happen here. Now, of course, the order of things is not guaranteed, but that's why we would need to set up a bit of an infrastructure to do things in the correct order. So when we go to spawn an entity, maybe we need to add in is animating as a parameter. Because for instance, when we go to spawn player, and then take a look at spawn entity. We force everything to start off as is animating. Yeah, at the moment we have not added in a way to specify the actual animating process. So this draws the texture, but it doesn't actually handle the animation. We have a lot of the infrastructure to do that. So maybe it should be this easy. Everything's kind of animating a little bit faster than we want. Like a lot faster than we want. But this is definitely a good step in the right direction. So we're going to add an additional parameter to the scene spawn entity. And now we have to update the calls that we make. Then on the gameplay scene, we also have to update this call. And then scene 302. Now, how do we go about capping the animation rate, huh? Taking a look at the demo in texture sprite am.c. You see that they use a frame counter to see if frame counter is greater than 60 divided by frame speed, and if it is, then we increment the current frame to the next frame. This corresponds to increment frame over in sprite.cpp. So if it's animating, then we increment frame. But we're going to need to attach a frame counter. There's animation frames, there's current frames, and then there's frame counter. So we only want the frame to actually change every so often. So if we increment the frame here, then we can set frame counter to 0 every time we do that. And then, well, if we wanted to keep track of like a total lifetime of frames, we need to do this. So every time we draw the texture, we need to increment the frame counter. So every 10 frames, we'll see a new animation frame change. This looks pretty good. And we can modulate the animation rate as we need to. We could even set it up so that every sprite has a different animation speed. So eventually we can actually add in a sprite on the ground that will allow us to attach a component with it to indicate if it's a hard surface or if it's collidable or something to this effect. And that way we can actually have a visual ground. But I think this has been a long enough video as it is, and I'm sure y'all are tired of hearing me talk. And I'd certainly want to get this video out to you sooner rather than later. So perhaps this is a good place to call it for right now. I want to give a big shout out to everyone who has been watching, liking, subscribing, and supporting me. Please continue to do so. Please share my content. I'm actually trying to build a game. I'm actually trying to teach y'all some computer science along the way. Thank you again. This is Dark Mage of @EvilDojo666. Signing out. Peace and take it easy.